So my goal in these problems is to express the sums in sigma notation. And just as a review, the key parts of sigma notation, there are four main parts. First is this sigma symbol, which tells you that you're adding. The second is the term, so this tells you what you're adding. The third is the bottom part here, which tells you when to start. And then the last number is the number on top, which tells you when to stop. Okay, so when to stop, when to start, what terms, and then this part here tells you what to do with the terms, what to do. So for instance, in physics, you'll see products and infinite products, right? And so it might be some, 1 minus epsilon to the negative n to the 1 over n, something like this, n equals 1 to infinity, right? And in this case, you're being told that you should multiply, right? And then we'll get into what it means to have this infinity. Essentially, we'll be working with infinite sums, which means we're taking limits of finite sums.
It's 13:45.
Okay, so back to this problem here, back to our problems here. We want to express this in sigma notation, which means that at the end of the day, we should have, since we're adding, right, so I'm looking here and I'm saying that we're adding, so I'm going to go ahead and put a sigma, so our sigma notation is what we'll use. Okay, so we're adding. Now, what are we adding? Each time we're adding, we're just adding the numbers. Each time, let's see, it looks like we're just adding I. Okay, and I starts at 1, and I stops at 10. Okay, let's do the second one here. So for the second one, again, we're adding, and it looks like what we're adding is, we could just write this as the square root of I. And I starts at 3, and it stops at 7. So that's one way to say this. So we're saying that we're going to add the square root of I starts at 3, and I stops at 7. Okay, now what about this one? Well, now we are going to be adding. This one is a little tricky because we go back and forth between adding and subtracting. Right, so subtracting, adding, subtracting, adding. So what are we adding and what are we subtracting? Well, here's where our pattern recognition comes into play. So it looks like the pattern is 2 over 3, 3 over 4. The next term is probably 4 over 5. The next term is probably 5 over 6, right? 6 over 7. So if you see the pattern, so we can put down here the term, 2 over 3, 3 over 4, 4 over 5, 5 over 6, 6 over 7, 7 over 8, all the way up to 19 over 20. Right? If I look just at the numerators are increasing by 1. So I could start off by saying it looks like I'm adding up something that's I starts at 2 and stops at 19. Okay, so what I'm going to do is I'm essentially going to build my solution. So it's not the case that I look at this expression and I instantly know exactly what I should write down. No, I'm going to notice, I'm going to pick up on patterns and adjust my answer until my answer is given. The idea of how we prototype Marshmallow Project in the beginning of the semester. So seeing, I saw a pattern, right? Fraction. And I could have some, and then down here my term. So my index, if I is equal to 2, because where am I starting? I'm starting with starting with I equals 2, and I stop at I equals 19. So I equals 2, I equals 3, I equals 4, I equals 5, all the way down to I equals 19. Okay, so for I equals 2, what do I get? I get, according to what I've written down here, negative 1 squared times 2 over 2 plus 1. All I did was replace I with 2, right? So if I equals 2, and then this is my formula, negative 1 to the I times I over I plus 1, then for I equals 2, this is what I should get. Negative 1, right? Negative 1 squared times 2 over 2 plus 1. That is the same thing as so this is the same thing as the negative 1 squared is just going to be positive 1. So this is equal to 2 over 3, which is what I wanted. Now let's see what happens for I equals 3. I'll have negative 1 cubed times 3 over 3 plus 1. And that's going to be negative 3 over 4. And that's what I want, right? Do you see it? Can you tell that that's what I want over here? Negative 3 over 4. And now for 4 over 5, let's see, for I equals 4, I'm going to have negative 1 to the 4th power. That's just plus 1. And I'll have 4 over 5. So I'll have 4 over 5, which is what I want, plus 4 over 5. Right? And now let's just check, verify for the last one. When I is equal to 19, I'll have negative 1 to the 19th power times 19 over 19 plus 1. Negative 1 to the 19th power is negative 1. 19 and then divided by 20. And that's exactly what I want. Good, good, good. Okay, so this is, so we have this is a solution. I want to emphasize that when we're doing these I'm just giving one solution. There are infinitely many possible solutions. I'm just giving one solution because there's so many different ways to use sigma notation due to the properties that we have that tell us when, when different expressions are equivalent.